All right, this is graphing quadratics in intercept form. We have the basic formula y equals a times x minus p times x minus q. Okay, at first this doesn't look like a quadratic. However, if you FOIL the two x's together, you do get an x squared. So it is actually a quadratic. All right, and that's one of the ways to tell if you're in intercept form or not, is that there is no power 2's, okay, but they are being multiplied together. Okay, so we have three coefficients we're interested in. That's the a value, p value, and the q value. So in this one, a is equal to 2, p is equal to 3, and q is equal to 7. So like vertex form, the p and the q will be opposite because of these two negative values here on the equation. So be sure to change those signs when you're using them in your formulas. All right, so as far as graphing, we're going to start with the axis of symmetry. All right, we have a very simple formula, x equals p plus q over 2. All right, so we're going to put our p value in, which is 3, plus 7, which is our q value, over 2. And we can see that's 10 over 2, which equals a 5. All right, so our axis of symmetry is x equals 5. All right, we then use that 5 that goes to the x value of our vertex. And then we have to plug in 5 into our formula to figure out the y value of our vertex. So f of 5 equals 2 times 5 minus 3 times 5 minus 7. Okay. So we just do some PEMDAS. 2 times 5 minus 3 is 2. 5 minus 7 is negative 2. And of course we get 2 times 2 is 4. And multiplied by negative 2 becomes a negative 8. So we'll put negative 8 there for our vertex. 2 is a positive number, so the direction of the parabola will open upward. Okay, and what's nice about intercept form is that it gives us the roots in the actual equation, so that p and q all are roots. So we just put them as an ordered pair. So we'll have 3, 0, and then 7, 0. Okay, again, remember to change p and q opposite from in the formula. All right, so let's go on to graphing. Graphing is very simple. First thing I'm going to do is plot my x-intercepts. So I got 3, 0, 1, 2, 3, and I have 7, 0. There's my two intercepts. Then I'm going to plot my vertex, which I already figured out, which is 5, negative 8. So 1, 2, 3, which is right there. Okay, and we have enough points to graph the quadratic. As you can see, it takes shape here. So I can do a rough trace of it. All right. If you'd like, you can add in your axis of symmetry. In there. All right. So let's talk about some important points. Well, we got pretty much the important points here. We got a vertex of 5, negative 8. And then we got our two roots, 3, 0, and 7, 0. Okay, and those are the only 3 points you need for graphing in intercept form. The transformation, remember, is based off our parent function, which looks something like this. Okay, so we're basically looking at how it moved. All right, so the a values in all the forms do the same function: reflection, vertical stretch, vertical compression. In this case, the a is 2. It's a vertical stretch, so we're going to go ahead and put vertical stretch by a factor of 2. Okay, from the parent function, it moves right 5 units. And then it moves down 8 units.